Here is practice problem 6, part of Euclidean geometry, grade 11. So this was taken from a past paper where it's actually 10.2. It says AB is the chord of the circle center O. OE bisects chord AB. Now let's just talk about the term bisect. Just to remind you, you guys know that when a line is bisected, it means that it is cut into two equal parts. So where we have OE, here's OE, that is going to bisect AB. Now we can clearly see that by these symbols. That means that AB has been cut in half, where we have AD being equal to DB. Then AD is 12 centimeters, ED is 8 centimeters, and OD is X centimeters. Now, before we even read the questions, what we know is that since AD and DB are equal to each other, DB is also 12 centimeters. So it's just good to have that there so that we don't forget about it when we need to do the calculations. Now, the first question says, determine the radius OB in terms of X. Now, here's the thing. We've got OB as the radius. And we also have OA as the radius. And there is one more radius, which is OE. And what you guys notice about OE is that we have the length OD and then we have DE. So the radius here is actually X plus 8, meaning that OB should also be X plus 8. Because remember, radii are obviously equal to each other. They go from the center of the circle to the circumference. So here where we have 10.2.1, OB is X plus 8. We can say plus 8 centimeters if you want to put the lengths onto it. So X plus 8 centimeters. Now it says hence, and you guys know hence means that using your previous answer, you're now going to answer this. Hence, calculate the diameter of the circle. Now you guys know that a diameter goes from one end of the circumference through the center and to the other end. But what do we also know about a diameter is that it is 2 times the radius. But before we do all of that, if we are able to calculate the radius, then we are able to get the diameter. Now a good place to start here is to solve for x, seeing that in the length of the radius you have x, which is unknown. So if you're able to solve for x, we know x plus 8 is the radius. So let's go ahead and try to solve for x first. Now what are we going to use? I'm going to make use of triangle, let's call this DOB. And the reason why I'm going to make use of triangle DOB is because this is actually a right-angled triangle. Now, how do we know that this is 90 degrees? You guys, your first theorem in the section that states a line drawn from the center of the circle perpendicular to the chord will bisect the chord. Basically, this is the converse of that. So we would have a line drawn from the center of the circle bisecting the chord is perpendicular to it. Basically, we have used perpendicular bisector. Now, I would actually prefer if you guys mention that that angle is 90 degrees and say perpendicular bisector as your reason before you go on to using theorem of Pythagoras, mainly because the 90 degrees was not given to you on the diagram. So remember, when it comes to Euclidean geometry, we do not assume anything. Yes, it looked like a right angle triangle, but you need to justify why it is a right angle triangle. So let's start off by calling this, we can call it angle BDO is 90 degrees, and our reason is perpendicular bisector. Now we're going to use the theorem of Pythagoras. So let's start off by stating it. R squared is equal to x squared plus y squared. So this is Pythagoras. Now, referring to the diagram, remember that the hypotenuse is always opposite the 90 degrees. So here our hypotenuse is the same as our radius, which represents r in the formula. X, now don't get confused with this, right? X from the theorem of Pythagoras, I'm going to take as the horizontal distance. So I'm going to take as the 12. And y, I'm going to take as the vertical distance. So as a standard measure, we always take x as the horizontal distance and y as the vertical distance. Although if you interchange it, it's really not that big of a deal, but I prefer following a standard procedure. Now, substituting in here, radius is x plus 8 all squared. Then the horizontal distance was 12 all squared. Vertical distance was x, so that's going to be x squared. Now let's simplify. On the left hand side, we have a binomial squared that is going to result in a trinomial. That trinomial is going to be x squared plus 16x plus 64. Now, how did we get that? Remember the shorthand method for getting a trinomial from a binomial squared. To get the first term, you square the first term. To get the middle term, you multiply both terms together and then you times by 2. And to get the third term, we square that second term. Now on the right hand side, we've got 12 squared. That is going to be 144 plus x squared. We are trying to solve for x, so let's gather all of the x terms. Taking this x squared over to the left, it is going to cancel out with the x squared that was on the left already. So we're actually left with 16x. I'm going to take the 64 over to the right. It is going to subtract 144 minus 64. That should be 80. And to solve for x, we are going to divide throughout by 16. So we get x is equal to 5. Now that's going to be 5 centimeters. So remember, what we need to get from here is the length of the radius. We know that the radius was actually x plus 8. So we're going to have 5 plus 8, which gives you 13 centimeters. But what the question actually asked was the length of the diameter. Diameter is, remember, 2 times the radius. So that's going to be 2 times 13. So the final answer for the diameter is going to be 26 centimeters. That is it.